mechanical reciprocating Lego with a rack and pinion, part 2. In part 1 I showed this model which does what I want it to do. In other words, it comes along, pushes the toggle switch which changes over the gears and makes it move in the opposite direction. It's big, it's bumbly, and I want to move on to different techniques of actually moving the rack. So here I've got another model. Need to try it, see. So down here we have my rack. Let's try see if we can get it a little bit larger. So here I have the rack, and on the end here I've got a device to push against this lever, and over here I've got a flat brick to push against this lever. In the middle I've got a carriage which whizzes round, hopefully. Oops. Don't know if we can see that. So the rack goes backwards and forwards, and as it's going backwards and forwards, in the middle I have a carriage. And the idea is that the carriage whizzes round in 2 different positions. So in this position, this black lever here is held in place by this red piece, and so therefore the gears are all in line. So my motor gear here is driving this idler, which is driving this idler, which is driving my output shaft down at the bottom, which makes the mechanism move in one direction. When it gets to the end, then it pushes the lever on the end, which lifts this red lever, which lets the black lever go, and it then goes round so that we have the white lever there pushing against this lever at this side. So that means that the main motor is driving, or the only motor is driving this gear, but that then drives this main gear at the bottom directly. Obviously these 2 gears here are connected together and are offset, so that when this comes round it touches the bottom gear, and then when it's released by this gear here moving out of the way by the end stop, then it comes up and then it comes into a line, so that the motor gear drives this idler, which then drives the output. So that's using levers, but it's a bit big. I like the way it works with its levers on here. I've had to put this big green lever over here so that this mechanism actually goes back, but it does go back and it seems to work reasonably well. So let's see, can we build a smaller version of that? Well, yes we can. Here's a smaller version. Might make it easier to see what's going on. Although on this one I did run out of Lego motors, so I've improvised with one of my own motors. This then uses this gear to drive this larger gear here, which that then is the input gear for the mains in. That then is connected directly to the motor, and we have another carriage here. We have our output here, and underneath we can see there's another idler gear. This works essentially in the same way as the other one, but I've tried to make it more compact and perhaps easier to see what's going on. So if we try it, is that the right direction? So we can see how, can we see it? How it goes backwards and forwards, depending upon the levers that stop it from moving. So we have our two levers then. Difficult to see where they are. This at this end is just a weight to put the lever back into the right place, and then it goes round backwards and forwards. We can see easier how the wheels there, the top three are in line, and then it moves down to the bottom one, and then it comes right round to connect to that one again. It only comes round under friction, so presumably it'll wear out, but it seems to work okay. So that's using levers to stop the carriage rotating. Have we seen the lever at this end? Are we tempting fate? So we can see there's a red lever down at the bottom. Can we see the red lever? Difficult to see it down there, down at the bottom. The red lever moves out of the way. The arm comes round and moves backwards and forwards. So that's using levers to stop the carriage going round. Another way to stop the carriage going round then would be to use pinions. I did originally, here's a different one. It has its carriage in the middle there. It has this arm here. This moves one way, and as it moves in and out, there's a little pin there that sticks out, and when the arms move that way, it moves the pin in, and then the elastic band pulls it back out again. We have a similar pin at this side, which unfortunately is difficult to see because it's black, but that pin then moves out of the way as well. We can see this red beast here which connects two rods together so they don't rotate. You can see how that moves, and that's pulling the pin in. We have our carriage in the middle, which is somewhat smaller. Ran out of Lego motors, so I've just put on this normal, a cheapo motor, driving the Lego. Be better if it was on the elastic band, wouldn't it? It was onto the pin, onto the small pulley. There we are. Right, do we think this one will work? Let's try it. So now that goes that way, and then it goes back again. You can see how the carriage rotates, only does a little bit, and then comes across and rotates again, rotating backwards and forwards as the gears then stops push against this lever. Seems a nice quiet, well not quiet, but a nice design that with the single lever in the middle. It does mean that I've got to have a fairly long end stop at this end, because of course the mechanism is out here. So that's one version using pins and a rotating carriage. So here's another version, similar idea, rotating pins Apart from the single lever, this now has 2 levers, which hopefully make it that I don't need the very large end stops that I had before. So this is going to come along and touch here and move it. This is going to come along and touch here and move it. They once again have pins on them, but on this one I've used this gear. I think it's a contract gear, I call it, so that they come round and hopefully have a better connection to it. Let's see if it will work then. Try plugging in. Is there a wire somewhere? Yeah. This actually has another Lego motor on it. So can we make it work? Yep, so there. Comes across, drives it across backwards and forwards. Hopefully we can see the carriage here moving to its 2 positions. Oops, don't get the wire caught in it. So this side now, this side of this gear is being controlled now, this side, and then the carriage rotates. There's half a rotation held in place by these arms on the pins, and once the pins are moved, the arm goes further. Not the world's best Lego builder. I'm sure I could improve my techniques, but I sure like playing. The elastic bands aren't very well stretched, but they are just enough to bring the pegs back in that stop the carriage rotating. So, more solutions to my rack and pinion rotating direction mechanically. Really got carried away with this project. But I've enjoyed doing it. So we'll see where we can go from here then. Right, bye now. Bye.